all you Greta's and Chutezcats. Welcome to Chapter 6, Section 3. What are the major types of marine ecosystems? So, we talked about land biomes. Now we're going to go into the water. And so we have two groups. We have marine, which is this set of notes, and that's the ocean. And then next set of notes is going to be freshwater. So, oceans cover about 71% of Earth's surface and hold about 98% of Earth's water. So, kind of important. We have four big oceans: the Arctic, Atlantic, Indian, and Pacific. They provide vital ecosystem and economic services. So they help with nutrient cycling, they help with food, fish, they help with tidal wave energy. The waves are happening anyway, we might as well use that, harness that energy. They help with transportation, they help with recreation, and they help with tourism. So we kind of need these guys. So saltwater environments, we have our aquatic life zones. So these are areas that can support life. And then biodiversity in an aquatic biome is usually determined largely by the salinity or how salty an area is. So often they're coastal areas: oceans, bays, estuaries, coastal wetlands, coral reefs. Big factors that help determine what kind of critters you're going to have there: the temperature of the water, how much dissolved oxygen, the food available, and the light and nutrients for those areas will determine what kind and how many critters you got there. So, coastal systems provide both economic and ecosystem services. They're going to filter out toxic pollutants, excess plant nutrients, and sediments, and they'll absorb other stuff too. They will provide food, habitats, and nursery sites to multiple critters. They also reduce storm damage and coastal erosion because they absorb a lot of the waves, and they can actually store excess water that's produced by storms and tsunamis. So we need these guys. Marine life zones. So once again, where life is found in the water. Water temperature, dissolved oxygen, and the availability of food, light, and nutrients determines the abundance, which is how many, and location and water depth of marine organisms. So most marine life zones are either in the coast, so you've got your estuary and coastal wetlands, or you have the open sea. So you've got three areas. You have three areas in the open sea. You have what's called the euphotic zone, which is the brightly lit upper zone. Literally means good light. You have the baffle zone, which is the dimly lit middle zone. So it's harder for sun to get there, which means it's harder for photosynthesis to happen. Then you have the abyssal zone, which is very dark, cold region near the ocean floor, where Nemo ran into the lantern fish. So less critters live down there. Major life and vertical zones in an ocean. So once again, we have the photosynthesis area, the euphotic zone, the baffle zone, and then the abyssal zone. Look, there's the fish. We haven't seen Nemo. You have your high tide and your low tide areas for the coastal areas. Often you have your coral reefs in this area. You have estuaries are going to be kind of in that area between low and high tide. You have your continental shelf. The water actually drops fairly quickly here, temperature-wise. So the euphotic zone, where it's sunnier, it's warmer, and then as soon as you get to that twilight bathel zone, bathale zone, the water goes down, temperature goes down very quickly. So ocean acidification is bad. Rising levels of acidity in saltwater. Now, saltwater itself is basic, but it is becoming more acidic, which is bad. It is still basic, and I think some people get tripped up on that. It is not acidic. That would be really bad. But it is becoming less basic and more acidic, which is the problem. So it's a result of excess carbon dioxide, or CO2, that's released into the atmosphere, mainly from the burning of fossil fuels. Oceans absorb at least 25% of this excess CO2, which is good to a point. We need that CO2 absorbed, but all that absorbed CO2 is going to react with ocean water to form what is called carbonic acid, which in turn reduces levels of carbonate ions necessary for the formation of coral reefs and many organisms, shells, and skeletons. So what this is resulting in is less of these carbonate ions in the water. So things that shells and coral reefs and skeletons need to build, the building blocks of these things don't exist. So they're getting very brittle, they're getting very fragile, they're dying because they don't have enough material to make themselves. That is bad. Things are literally dissolving away in the ocean because they don't have enough carbonic ions. So humans have tons of impacts on marine ecosystems. So Half of all of our coastal wetlands have been lost to agriculture and urban development. More than 1/5 of the mangrove forest, if you've been to Florida, you've seen those, lost to agriculture, aquaculture, and development. Beaches eroding due to development and rising sea levels. Ocean bottom habitats are degraded by dredging and trawler fishing. A lot of fishing is detrimental to the ocean. Not only are you taking the fish, you're destroying everything around it. And at least 2% of coral reefs are severely damaged, and 25 to 30% are more threatened. This data is 3 years old. I'm telling you right now that number is definitely higher now. For coral reefs, they have to deal with ocean warming, rising ocean acidity, rising sea levels, soil erosion, algae runoff from fertilizer, algae growth from fertilizer runoff, bleaching, increased UV exposure, damage from anchors from fishing and diving, and then overfishing. So we got a lot of issues going on that humans are being stupid and things are dying. All right, and we've survived this round of notes. Before we leave, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And if I don't see you, good afternoon, good evening, and good God, do your homework.